Okay, hello folks. I'm Andrew Connolly. I'm a member of the marketing team here at Synadia. In this next session, we're talking to longtime NAS users and Synadia customers, MachineMetrics. MachineMetrics provides an industrial IoT solution, giving manufacturers real-time insights from their machine data. But I'm not going to steal any more of their thunder. So with me today from MachineMetrics are Jochen Rao and Tyler Schoppe. And I'm going to let them introduce themselves here briefly.
Yeah, hi, thanks for having us. My name is Jochen Rau. I'm the engineering manager of the data platform team at MachineMetrics. It's one of three teams. And as you said, we're an IoT company, and we're connecting to thousands of machines at hundreds of customer sites and factory floors. And NATS came in very handy, which we would talk about today.
Yeah, and I'm Tyler Schoppe. I am a staff engineer on Johann's platform team and also our in-house NATS evangelist.
So yeah, our tech platform basically was a traditional AWS-based platform. We use a lot of, and we're still using AWS products like Kinesis for streaming and RES databases, S3 buckets, and so on. And we have a lot of deployed edge devices, thousands of edge devices that are the machine connects to, right? Those little green boxes. I have one here. And on those, we can't really run a good POPs, or we haven't run a good POPs solution. And so we were searching for something that actually can work as Kinesis, but on the edge device. And then we looked around, and NATS was actually, because of the size of the binary and the resources, or not that much resource that it uses, was very attractive. And the philosophy behind NATS was very attractive, as it allows us to basically decouple where data is consumed and where we have our compute. So we can move around very freely, compute, and data is ubiquitous, right? We don't have to care about where the data is produced and where it is consumed. We have this freedom. And that was the initial point where we tested different solutions, different vendors, but NATS, from our perspective, had the right philosophy, right?
Very nice. I love that you have the edge device there right with you to show off. Makes for a perfect segue. So I think I described MachineMetrics as industrial IoT. Can you give us a little more background or color on what that looks like in practice? What are the, couple core use cases that you serve to your customers?
Yeah, our typical customer is a mid-sized shop, factory floor. They have dozens of machines. Usually, they have individual operators on the machines. They might walk around the machines to operate and provide material and kind of set them up for a new product, for a new part that they produce. But in general, how they work traditionally is they have spreadsheets, they have paper to coordinate their work, to know what the machine is doing, if the machine is active, how well they actually utilize their machines. They're very expensive, right? So they want to utilize them well to reduce costs. And that is a challenge with kind of very different vendors of machines, very different machine controls, and so on. And that's where we basically traditionally come in and say we can connect to a lot of PLCs. Those are the controls of the machine. We can gather data. We have sensors that we can put in to, for example, count parts if that's not delivered by the control. So we collect a bunch of data from different machines, and we ingest that data. That's the traditional way. We ingest that data into the cloud, and then we contextualize it. We provide connections to ERP systems. Those are the planning systems that factory floors use on the higher level, right? So what are the products or what are the parts that we need to produce, and delivery deadlines and so on. And so we connect to those systems, contextualize the machine data, and provide analytics on top of it. And essentially, our customers, they log into a dashboard and see a lot of analytical data. They can do planning for their production. They can do production planning. and steer their production, and also be alerted if something goes wrong and so on. So that's what we essentially deliver. On top of that, we have also solutions for tool monitoring. So for tool breaks, that's very expensive, right? We want to predict, or we can predict before a tool breaks, that it will break in the next few cycles, so they can change it without having a catastrophic incident on the machine that costs a lot of money and time, right? So we have that, and that's once foremost on the edge device as a compute, right?
Okay. So it sounds like the big theme is these machines on factory floors throwing off valuable data of all kinds. Um, but it was not easy always to get it, to get access to that data, to get that data to the right place. Um, so Tyler, it sounds like NATS was in place to some degree when you got to MachineMetrics. Can you talk about how you guys have grown with NATS, maybe how it was first used in the solution and how it's grown to do, more different things?
Yeah, certainly. I mean, like what Johan talked about, we have so many edge devices out in the field, and that works really nicely with the leaf node model that NATS provides. So that hub and spoke type of architecture. So that was really one of the initial use cases, right? So having all of our edge devices have the ability to communicate from where they are back into our cloud. Um, we've started to just extend and really build upon a lot of the different features within NATS, just since it can do so many different things. And as we've started to build more distributed systems, it's just become that really core mesh layer for service to service communication, and just being able to do so many different types of building patterns using one tool that's familiar just makes it easy for, once you kind of get the basics of what you're doing with NATS, you can continue to just kind of move quickly, really handle, any kind of different situation you want to use. So a lot of it just started out as kind of doing some simple service development with core NATS, and then that's certainly expanded into some really pretty heavy Jetstream usage, work queues, lots of different processing that we use, especially with the consumer model, just makes it so easy to scale services as you need, up and down, really with just one piece of code that can just expand and shrink as you need. We've really started to leverage key value as well. I mean, just so many of these tools that, Johan mentioned on like the AWS stack with Kinesis and Elasticache are things that we do continue to use just based on, their prevalence within our architecture. But new development really is just all things that are on NATS, using Jetstream key value.
Yeah, I think that's an interesting thread to pull on. How how do you guys think about decisions around replacing existing tools with new tooling like NATS? Is it generally new development gets new tooling, or are there scenarios where you will rip and replace to get some benefit?
Yeah, I think we've seen both in practice, right? Where, we need to be able to move quickly as, a small team. So, the challenge of saying, oh, let's just replace Kinesis with NATS for all our data ingestion is, a massive project that is something we are hoping to get to. But, you know, is it always worth the time right off of the initial rip? But for a lot of new development, it's pretty much just NATS. And then we've seen in some cases too, when we want to have higher levels of guarantees, that it might make sense to use NATS over, say, something like Redis, just to get, better pub sub guarantees with stuff that we have like on internal message brokers. And when we need to know, exactly once guarantees, that's the tool that we want to use for the job.
Hmm. And how about the interoperability? So when you have a legacy stack and you're adding on new things, using NATS to add on new capabilities. Do you find that things play well together? Has that been easy? Have you had to come up with strategies to manage that or handle that?
Yeah, that's a pretty good question. I mean, we've certainly used NATS in a few, different stacks. We currently have NATS in production in JavaScript, TypeScript, like Node environments, as well as some Rust and Python services. We're a pretty heavy JavaScript shop, and we have spent some time as a platform team putting together some intermediate tooling on top of NATS so that it kind of abstracts away a lot of the interactions with NATS. So it can more be along the lines of we want access to this data or we want to produce data, and you never really need to deal with setting up a NATS connection or even understanding like the specific subject that you want to publish on. We have tools that will say like, this is the data that I'm working with. Here's where I want to put it. Here's where I want to consume from, just so that it's even easier for developers to work with and helps us to maintain standards. Because one of the big lessons we've learned with using NATS is that the shape of the data, whether that be subjects or payloads, is very, very important, and you need to be very intentful about how you set that up. So we're trying to make that as easy as possible for our development teams to take it and run with it and not have to spend that much time in some of those trickier areas.
Another example of where we interface with existing architecture or with existing infrastructure was the Kinesis stream that we have. We have several Kinesis streams like processing stream, but we basically take the end of that Kinesis stream and copy it into NATS, right? So it's mainly consumed through NATS now, the whole stream. And that enables us actually to produce machine data directly into NATS on the leaf node. Kind of bypassing the whole Kinesis pipeline. And now we have a migration path. We can say more and more machine data, more and more specific data is on NATS then. Right? It gives us this nice way to gradually switch over. So we have now really more freedom. And one of our initiatives in the future will be to move our processing that is solely cloud-based, right? So contextualization more onto the edge device. That's one of the things that was the goal, and NATS allows us to do.
Very nice. Can you say anything more about the motivation for wanting to do more processing at the edge, and maybe what's changed that is making that more of a reality to do it at the edge?
Yeah. So, for example, tool monitoring. Tool monitoring requires, usually what we ingest is data at about 1 hertz, one data point per second per metric. So roughly, right, depending on the machine, the control. But for tool monitoring, you need about a kilohertz of data. And that is usually not, given the bandwidth that factory floors have now, you can't move that into the cloud. It's not necessary, right? Because if you have the compute then on the edge device that can look at that data, process it in real time, low latency, and then just send the alert up into the cloud, that's plenty enough, right? And so we moved that. That was a requirement more on the data side, on the data velocity side, right? But it's also resource usage. There's a lot of untapped resources on the edge device. They are not high-powered edge devices, but still we can move a lot of computing that we have usually in a service in one pod running on Kubernetes, right? We can distribute that on the edge devices with no cost at all, right? So it's also use the compute resources that are out in the field more and reduce the cost in the cloud. Right? That's another kind of capability. And then it's also having individual deployments, kind of customer specific. So that can be on an edge device, deployed to an edge device more easily. So it's kind of the important part is not that we want to move a lot of compute to the edge. It's the freedom that we don't have to if we develop a service, we don't have to think first and foremost about where it's gonna end up on the edge or in the cloud. It's just then constrained by resources.
Do you guys struggle or face challenges around connectivity at all? Are there situations where edge devices are, intermittently connected or disconnected, and how does that work with your architecture?
Yeah, I mean, we see basically, every extreme, right? From customers who have great network setups to those who have very poor network setups where the bandwidth is super low, in troubleshooting scenarios or with, just local environmental things, right? Like we've seen with some of the fires in California or flooding in the Carolinas, right? Shops, all of a sudden, boom, the power goes out and then when it comes back on, who knows if the network is available. And that's really starting to drive a big push. We currently don't use Jetstream on our edge devices, but that's something that we want to, and we're planning the work right now to get that going so that we can have that persistence layer so that the edge device can continue to capture data and, keep going as business as usual. And that again is, a great use case for compute on the edge so that in the case that you don't have that connection back up to the cloud, some features can still be driven just within your local area.
Yeah, and traditionally we have SQLite running on the edge device that buffers data, right? But that is also a break in technology. Like, you put it in there, you take it out, you have to serialize it, deserialize it, and then put it up into the cloud. So it's just a buffer thing. And with Jetstream on the edge device, it's the same technology. You just write it to NATS, and it's gonna be persisted until it's reconnected, right? And then it's gonna be synchronized up into the cloud. So there's no technology break anymore, and that's reduced complexity, right?
Mm-hmm. Yeah, I was going to ask a question around um, operator experience and developer experience with regards to NATS. How has NATS changed those experiences? Is there something that stands out as the biggest quality of life improvement for you and your teams? Something that um, has made your day-to-day easier or different?
I'd say I let Tyler speak to that. I'd say it made it actually possible to pull off some of the things we do, kind of the ease of use and operation of NATS with a small team. I couldn't imagine, for example, I worked with Kafka in the past, but you have to have a lot more kind of resources to actually operate the system, just on the operational side, right? Um, to do that. And with NATS, it was very easy to get into vanilla NATS, especially, right? It's just basically started, have the pod run out, and you can connect to it, and it works, right? So the operational overhead is so minimal for vanilla NATS, and also for Jetstream is a little bit different depending on how complex the setup is. But vanilla NATS is so easy to set up and operate. We couldn't have done it with a different technology.
Yeah, I think in terms of you definitely hit the nail on the head with operating NATS. I mean, it's so easy to get it up and going. And when you run core NATS, it's probably couldn't be really much more simple. Getting into Jetstream, there's a little bit more that, of course, you need to think about. But when you do compare it to some of those other systems, like you mentioned with Kafka, I mean, it's considerably easier to manage from that standpoint. And I think from just like a developer quality of life, once you do learn the tools and you understand some of the development patterns, it just unlocks so much potential. And again, like using that same tool just to do everything, it just feels so familiar. It's just kind of second nature. Like, oh, I know exactly how I'm going to build this. Just pull up a stream. I can have a shared consumer to just handle like a scaled workload, add in some key values to distribute configuration or some short-term caching. And again, like the architectural possibilities that we now have really changed just with our traditional stack. It's very directional. So from the edge to the cloud through some kinesis streams, different layers of processing, but it's all data that's kind of headed in one direction. Whereas now, we really do have this, ubiquitous data plane where you produce, where you consume, any type of compute can kind of live really wherever, which, like you had mentioned with tool monitoring, kind of opened up, a new possibility for something that we could do. But that doesn't mean that, the compute that's done on the edge can't be done in the cloud, right? Like we can put it where we need it depending on a lot of different scenarios.
Okay, sounds good. Maybe a different topic, just to, scratch some new surface area. Are you guys using NATS at all for anything front end, dashboarding, WebSockets, anything like that?
Yeah, that's actually a part of some of our work that we're working on with the developer libraries that we're putting out, is to make that stuff more accessible for the client side. We have a little bit of work to do on our end with our account structure to enable Jetstream access. But yes, we issue short-term NATS credentials through our APIs, so that clients as well as edge devices can have location-specific credentials that they can consume their data. But that's certainly a huge use case that we're seeing our internal teams are really clamoring for as we start to build some more like micro or front ends, smaller front ends outside of our typical UI stack, where there's so much data that we have on NATS, and especially utilizing key values, where they don't have to go through kind of our traditional stack of, just like a React front end going back to like our Node backend through like an API layer that, just your kind of traditional like MVC architectural pattern. But it's like we can skip that middleman and have access to so much data where we can just show customers things, build features that live really powered by NATS. So definitely a huge case that we're looking into now.
So just so I'm following, is that front ends for customers consuming MachineMetrics data and analytics, or internal teams wanting to consume NATS data?
Internal teams that want to build things for customers
Oh,
is what we ideally want. And as an extension of that, we have some customers who are, power users and they want access to our data, where we've started to provide them with data via MQTT, but there's really no reason that we can't just, be able to issue a user NATS credentials for their account and say, here's sky's the limit. This is your data. Do whatever you want to build on top of it. Because we do see so many of our customers they want to build something specific just for them, and they have development resources, and there's no reason we should tell them no. But really, we want to be able to say, here's all your data, build what you want with it.
We have a handful of customers that consume MQTT data directly from NATS, basically. And that's also a really nice feature because most of the IoT space is dominated by MQTT, right? So
yeah.
having
And
that basically out of the box for free is incredible, right?
yeah, that's an overlooked and perhaps undermarketed feature that we are working to say more about NATS as an MQTT broker. What has NATS unlocked for your product or platform roadmap that is coming in the future and is only possible because of NATS?
When we talk about distributing compute and just what is opened up using NATS as a transport layer, especially when it comes not just to data, but like you take, a WASM file, that's something that can be sent over the network. And now we're talking about pieces of code that can just be brought down to an edge device, something small. So we were just talking about, rather than just like, OCI pulling from AWS ECR to bring down a massive Docker image, you have a piece of code that could live in a NATS object store. and then that can be just distributed everywhere automatically, like down to edge devices. So, you would need this piece of compute there for, say, tool monitoring, and boom, it's right there. Something that even in a low network scenario is doable, because we're talking kilobytes, not 100 megabytes with like a Docker image. So yeah, it's just like, it's just so cool.
Um, is there anything in particular about NATS that you see as the standout capability, something that uh, defines NATS to you, or that you couldn't live without, that makes it that gives it its unique magic?
I have something a little bit obscure, which is the NATS, I think, as the only technology in that space, really decouples the addressing of data from the access point of data. Right? If you think about a classic RESTful endpoint API, the identifier you say, this is the data I want, is the same thing as the access, right? There needs to be a server that is behind the URL. And the URL itself, it's a URI, right? It's an identifier for the data that you want, right? And that led to all kinds of conflicts, I would say, or suboptimal architectures, right? And with NATS, you have that separated. You give it a set of server connection URLs, and it can round trip, it can gossip which servers can you connect to. So that's very resilient. And then the subjects are actually addressing the subset of data that you want to look at, right? That you want to consume. And that separation is an absolute, I think, unique and powerful feature in NATS that is, I think, underappreciated. And once you use it, it leads to a very kind of free architecture and a high resiliency, right?
Yeah, something along those lines probably would have been what I would pick. I mentioned it a little bit earlier, talking about, just you're not just pushing data in and pulling it out from somewhere. But I think alternatively, decentralized auth model has
Mm.
provided us with just a whole mess of benefits. It's certainly a topic to spend some time making sure that you understand thoroughly, but it really just unlocks so much. And I mean, for us to be able to have that separation of customers' data, so an account per customer, but then be able to map things back into an account that we own, to have access to just all the data, how easy it is to just manage, with Schoppe signing keys, to then issue users, you want to revoke something. It's really just as easy as making an administrative change, and you see things happen downstream. It's a really, really powerful tool to have at our fingertips.
Very cool.
Mhm.
My final question. So you highlighted decentralized auth as a perhaps tricky and carefully configured bit of NATS. Um, how have you found both the NATS community and ecosystem for getting into these deeper topics, and how has partnering with Synadia been beneficial in getting NATS to prod, getting NATS to scale faster?
Yeah, I mean, I think within the NATS community, there are a lot of great resources. The Slack channel can be a good place to ask some quick questions, but through like the Rethink Connectivity YouTube series is a place that I have referred to many times and still do, just for like quick refreshers, especially on decentralized auth. The video there is fantastic for helping you to get started, and that's only gotten better with our partnership with Synadia. The team of solution architects is, of course, unbelievably knowledgeable, and they're just great people to work with, and super quick to just respond to a Slack message, and with some great insights. And they've already been very helpful for us as reworking some of our auth model is a big project that we're working on right now.
Fantastic. Well, Tyler, Johan, thanks so much for your time today. I really enjoyed learning about NATS at MachineMetrics. It sounds like you guys are using NATS really to the fullest, and I look forward to checking in the future and seeing how Jetstream at the edge is going for MachineMetrics. Thanks so much.
Yeah, thanks for
Yeah.
having us.
Now we have Johan and Tyler joining us live to answer some of the questions that have been coming in during that session. Again, thank you so much for your time talking with Andrew, and thank you for your time today. So we have a couple great questions that came in. I saw you actually typing to answer some of them, which was excellent to give a lot of detail. I really liked in particular the answer where you talked about, well, so here the question is, how do you deal with your payload schemas, you use a registry, documentation, async API? And Johan, I think you had a great answer for that.
Yeah, so what I type was we have developer libraries that encapsulate our domain model, and also not only the payload, but also the subject generation. So developers don't have to focus on how they generate subjects. They can just say which part of our domain model they want to look at and observe, and that's making it very easy for developers to get into that. They don't have to know the details of underlying nets even. So they can generate their subject automatically. The connection is handled for them. And also payload. We have a lot of different events, obviously, and that takes up a lot of time to develop. That's actually the major point. If you use NATS, it's just not dropping everything into NATS, but kind of controlling that. And we did that with those developer libraries that also self-documenting. Like we use cloud events as the envelope format. That's it's a standard, and the cloud native standard, and that has been very helpful in encapsulating it and deduplicating data on NATS and through message ID, and also giving some stability of what the consumer will look at, right? And so we define that in those libraries.
I liked your call out in particular to the domain model library. So you had some really cool tech with that going between Rust and TypeScript. Do you want to talk a little bit to that?
Oh, yeah, so because we have different primarily we use TypeScript as a language, but we also have different languages, and we wanted to support all languages. And so the domain model library is actually written in Rust, a very type-safe language, which we use also for deploying compute, right? Our newer compute is all written in Rust if it operates on data. And we translate that Rust into TypeScript using wasm bindgen. So it's going to be imported as a normal NPM module, and developers get code completion out of the box. They see what the domain model looks like. They can extend it, and also the subjects you can see what is available as kind of a part of a subject. We have complex subjects to be able to subscribe, for example, only to machine, only to specific data categories like quantities or states of the machine and so on. That can be very complex, right? And so we're making that easy using that kind of technology. And using Rust has been very good with the Rust library. The client library for NATS is also fantastic. So.
Excellent. We got one more question here. So which tooling do you use to create and manage the credentials and keys and permissions for the edge nodes in particular?
Yeah, I can speak to that a little bit. So kind of like I mentioned in the interview, we're going through a little bit of a transition right now. But as we speak, most of what we do, we set up a lot of the credentials and whatnot for decentralized auth, just using NSC CLI. And then we use those account seeds to issue short-term user credentials out via some of our APIs, so that our edge nodes can reach out and connect with some short-term credentials that will refresh, and then gives us a little bit more of a dynamic way so that we can change credentials on the fly if we need to. The same thing goes for UI clients who want to get user credentials, and that's currently done through a single account, and then we use some code in the back end of the API so that we can specify that to specific companies, obviously, so the data stays isolated. But that's a project, like I mentioned, we're working through with the Synadia team right now so that we can expand so that each different company can get their own account so that there's better isolation of data, enables us to do some different things over on the edge device, just as well as some better security posture from our standpoint.
Yeah. And in the future, we will use the Synadia control plane, and especially the API that comes with that, the RESTful API to basically issue user credentials, set up accounts, and so on.
Yeah, that's a really good point because we started down the path of trying to roll that ourselves using some of the underlying APIs. But now that you can do that through the REST APIs in the Synadia control plane, it is considerably easier. And we're monitoring a lot of events around, automating that with like some change data capture stuff. So we see it come through NATS and then we can react to it, at that level as we need to say, create another, new account. So we can support another customer that's onboarding.
Nice. And I know we will be hearing a bit more about Synadia control plane later today as well. We have a session dedicated to that with some updates. We'll do one more kind of fun question here, but first off, do you remember how you discovered and first used NATS and relayed your use cases prior to NATS? How were your edge devices communicating with the cloud?
Yeah, so we were set up as AWS shop, and our edge devices communicated through WebSocket, basically, and data came into Kinesis and is processed there, right? So that's a traditional way. We were looking into expanding our streaming data. Was kind of, we were in streaming thinking, right? To the edge more on the edge device, and we were looking into different vendors that provided lightweight pops up, and that's where we looked at NATS, and that's basically won out really quickly because of the philosophy that is behind NATS, of kind of making data ubiquitous. You're not thinking in streaming from A to B. You just say, okay, I'm producing data somewhere and I'm consuming data somewhere else, right? And you don't have to think about this from A. How do you get the data from A to B and then do something with it, right? So that was kind of the winning argument early on, right?
As we wrap up, did you all have any other closing thoughts or anything you wanted to share before we move on?
I would say if you're in the IoT space, try it out. I mean, NATS has been very good to us in that regard, and the leaf node concepts is just a very good fit for IoT use cases. Absolutely, and it's easy to just try it out and get into it.
Yeah, I mean, kind of like Derek mentioned in the keynote, so much is moving over to edge compute, and NATS really helps to make that super easy. So it's a great technology, definitely worth trying.
Thank you both so much for joining us, and thank you for sharing your story.